everyone, I'm Shomajit Boshak from team Enervision, and today I am here to present to you our software side of the project. Our problem statement was to build a system that will help microgrid operators raise the efficiency of the power consumption by 15%. And we thought that in today's India, a major problem is that many microgrid operators, especially in rural areas, don't have the necessary knowledge to properly use the energy to its utmost efficiency. To solve that problem, we decided that we are going to take all the data from a microgrid, digitize it in a way that it's easy to understand even for non-tech savvy people. So we're taking the data, we're pushing it into our website, and we're showing it in a way that the users can just log into the website and our application, take a look at the dashboard, and they will have all the necessary things they need to know. First of all, you can see this is our dashboard, and in the dashboard at the very top, you can see this is a basic data. This part is here is how much solar energy is being generated by your setup. This is how much wind energy is being generated by your setup. This is how much total energy is being used or consumed by the home appliances connected to the microgrid. And this here is obviously the battery section that will give us how much power we have in our reserve. If we scroll down, there's this power overview chart. In this chart, we can see a comparison between average solar generation, average wind generation, average total generation, and average consumption. We're using a chart because charts often make data easier to understand to most people. We have different time intervals. By changing the time intervals, we can check the graph in different ranges. Beside that, there's this recent alerts and system status tab. We can see if the system is online and whether the performance is optimal or non-optimal. Also, if there are any malfunctions in the grid, the alerts will show up here. Like you can see here, this is we have some energy deficit alerts. If we scroll down even more, we have the solar analysis chart and the battery and power flow charts. This will give us the sun intensity, a graph in comparison to sun intensity and expected power, from which we can deduce whether the grid is working at its full capacity or whether there is a malfunction that is preventing it from generating as much power as it possibly can. In the battery and power flow tab, we can check the grid import export status along with net power flow and battery level. This will help us monitor the battery health of our setup. If we scroll down even more, we have today's current day stats. This will give us how much power we have generated, how much consumed, how much we have exported to other grids, which is a feature we are working on. We have added a energy trading bonus feature. You can see how much per unit of energy is going for at the current day, and from that we can calculate how much money we are saving by using the microgrid and not state provided electricity, and how much we can earn if we decide to sell this electricity. Under that, we have added a AI feature. Here you can just enter one of these and the AI will give you the necessary information. Let's say we need the battery status of our device, so we'll just click on battery status and the AI will give us how much battery we have left, how much capacity, and how much estimated runtime we have at our hands. From there, we can see there's this analysis tab. In the analysis tab, if we go there, we can see the energy analysis data, everything we need. Here, this is the sun intensity versus solar power generation data in a much more defined graph than the previous one. Here we can see the recent energy trading analysis, the recent trading opportunities. If we scroll down, there's the fault detection result. It's giving us if there's any fault from comparing sun intensity and power generation. Let's say there's this malfunction in the setup that prevents it from generating as much power as it can from a given sun intensity, then it will show up here. And we have also included machine learning that will make predictions according to previous times data, and the predictions and recommendations will show up here. Now if we go to the alerts tab, this is a much more defined alert tab than the previous one. If you come here, you can see how many total alerts you have, how many critical and high alerts you have, how many unread alerts you have. You can acknowledge them all just by clicking on this one button, and you can also filter the alerts by their priority or severity levels. You can filter them from the types. If this is a fault detection alert, you can simply select fault detection, and you can see there is no fault detection alerts as of now. You can see there's an energy deficit alert. So if you go to the energy deficit, it will give us all the energy deficit alerts. All types will obviously give us all types of status. From here you can select the status, unread only, acknowledged only. We can filtered the alerts based on this alert distribution. You can see how many alerts in how many sections we have. We have one alert in trading opportunity, 28 entry deficits. This is all mock data for now, so there's no need to be concerned. If we go to user management, in user management you can see how many people or how many users are connected to this one specific grid. In here we can also export user data. We can just click on this button and it will give us the user data. We can open it in Notepad or any other app and see how all the data about all the users that are connected to this. Here you can see 1 2 3 4 5 total you can see total 5 users are connected to this particular grid. And let's go back to the dashboard now. The dashboard is basically a place where all the data is shown in an abridged form, and you can go to the respective tabs to see them in more detail. We can enable or disable the grid status from here. Since we haven't connected the hardware part yet, the grid has been disconnected for now. And yeah, that's all for the software part. The hardware part will be described by my friend Kaushik in the later section. Thank you.
Myself, Kaushik Mandal from the team Enervision. Our topic is real-time microgrid monitoring system for renewable energy. I am going to explain implementation of IoT sensors and microprocessor to our project. Start with microprocessor. We will use the ESP32 microprocessor. To get the data from the generation circuit, we will use INA219 to measure the current at battery charging, and PSM0040 sensor or voltmeter to measure the voltage at there. Now coming to the microgrid, to measure the load and at the grid, we will connect ACS712 in series to measure the current as there is AC current, and will use PSM0040 for collect other needed parameters data for analysis. We also use a solar intensity sensor to estimate power generation. I have attached a schematic diagram of total IoT circuit. Thank you.